Oh, and good morning, everybody. Hope you are ready for a exciting webinar on golf course irrigation. So we have a lot of fun things to show you on how Land Effects can handle golf course irrigation. I see a good collection of skilled designers here ready to watch. I really appreciate you guys tuning in and share with us some because of course we do require a lot of input from y'all. We have the notable handicap of never actually designing a golf course irrigation, so it's been a lot of interacting with designers, and so when you have someone right in the same room with you, there's so many hundreds of little questions that are really necessary to really fine tune it. So do want to throw that out immediately that we're definitely going to be improving this even more, and we do need a lot more input from you. But this is definitely representing a number of years of continuing to add on to our irrigation capability with the tools specific for golf irrigation. And as a lot of you know, it obviously does fit the bill, but we're going to really showcase the combination of tools and how to use them and how that all works. But do feel free to chime in with little questions there. I'll be here. I even have a good number of golf jokes teed up. So as there are moments where Jake lets me, I'll do that. But so enough of that, and take it away, Jake.
Awesome. You can hear me, right? All right. So as Jeremiah stated, I am definitely going to be the first one to tell everybody I am not a golf course irrigation designer. I know irrigation very well, but golf course is one that I have not dabbled in too much. So putting this together was very interesting. I learned a lot about how our tools worked. So hopefully, with your guys' help and comments and questions, definitely give them to us so that either you can teach me what I'm doing wrong, if you're looking at our plan as we go through this example, that you bear with me and give me a little bit of slack. Just know that I'm a baby at this. So having said that, we do want to hear from you guys as far as the procedures and practices that you guys have come up with as you use Land Effects. We know just as much as anybody that this program isn't going to handle everything, and you're going to be using all kinds of different sources on top of Land Effects to be able to get the final output that you need, and for what it is that you actually are using Land Effects to do calculation wise for your system. So just keeping that in mind, we are going to just go over the understanding of using right equipment and how to utilize that a little bit better. Understanding some of the key components that do go into an actual golf course irrigation system, and how we were able to really tailor some of these tools in combination with each other, focus solely on golf course specific design. So just a quick overview of what we're going to be going over. We're going to be definitely understanding valve and head rotors, shut-off valves, what those will do for the system, a little bit about just the fact that we do need to think about controllers and stuff just the same, and as we run our valve schedules, how we can get the proper wire lengths and stuff like that, and then obviously joint restraints. Something as vast and as big as a golf course irrigation system is all mainline, and it's typically mainline. You can have regular valves with laterals, but for the most part, using those valve and head rotors means that the lines are constantly charged, which means you've got large feeder lines that come around your whole course, which require joint restraints so that you don't have those expensive breaks and loss of water that you can hold your system together. So we'll show a couple cool little tools there too. Going into flow zones, how we actually make things easier when it comes to sizing the main line. So we'll cover how to really use those flow zones and what they actually do. Obviously our main line versus lateral line, we are going to use both pieces of pipe, but they are all considering this main line. So just how we're able to use lateral line within the system and how the system's actually able to recognize that it's indeed mainline, but let the system actually speed up the calculations as it goes through and sizes things. Spot elevations, very important. Undulating golf courses, the terrain's all different. Spot elevations throughout the plan is definitely a key thing that you should be putting onto your system so that it can help calculate those pressure losses or increases. And then just a couple scheduling options as we go down through the end of it, helping troubleshoot certain things and how you actually start to wrap your mind around if your design is going to be compatible with how much of a water window you have and stuff like that. So throughout, I'll definitely have plenty of time for any questions or comments, as well as Jer's fun little jokes. So not belaboring that too much more, we're just going to jump right in here. So the first things that we really want to understand, right, are that golf courses in general are definitely something that is brings a whole level of complexity in and of itself, from what your water source is, whether you're pulling from a well or a pond or a lake, or just all those different things, how you specify your equipment, what can handle that kind of stuff, the pumps that are needed, what kind of stuff gets into the system, whether it's sand or algae or little critters from the pond and stuff like that. So, we're not going to go over exactly how to specify things. I think who we're talking to now completely understand what they've got to do in regards to that, but being able to have the power to come in and choose our valve and head rotors and specify, the actual manufacturer and see what they have available for your golf course design. And just like everything else, being able to click through and find, the specific model that you need and go right to their website and right to their catalog for this stuff. Just bringing that power right to you so that you don't, have to second guess anything as you're, placing the stuff that you're looking to do. So I've already added a couple of things here, so we're not going to add any new stuff, but we do want to obviously think about everything that we're going to need for this system. So being able to know that we're going to use valve and head rotors, putting those valve and head rotors into your plan and place it into your drawing. Land Effects sees those and starts to treat different tools differently when they see that. And we'll go through that as we talk about our lateral piping and shutoff valves and such like that. But just know using those valve and head rotors does open up sort of this golf irrigation design door for the system that it wouldn't normally do. So definitely want to have those in our drawing. When we talk about valves, we can obviously add a quick coupler, so I am going to add one of those right now. I did not add one of those things, so we'll just go ahead and choose one of these guys here, not too worried about what kind it is. And then obviously we have the ability to have shutoff valves. And the shutoff valves are super important for this design, not only pertaining to maintenance, because when you're a greenskeeper or the person out there doing the maintenance on this thing, shutoff valves are extremely crucial, especially when you're breaking up this type of a main line and this loop system, being able to shut down pieces of the site without affecting the rest of it. So understanding the need for these shutoff valves, and then not only on the maintenance side, but actually as we get into sizing the main line, being able to toggle those on and off. You'll see the ability to have it open and closed, and what that actually means for the system and how the system recognizes that. We'll sort of go over that a little bit more in a second, but and then obviously just choosing the actual valve that you're intending on putting in. So from there, we have our auxiliary equipment. We can add our controller if we have central control. But something that Jared and I were battling back and forth, or talking back and forth about, is we're actually going to show you how to use a combination of schematic irrigation and using caps as you are in those first initial phases of your design. So you're not necessarily placing everything right up front, but just to give you a sense of what that main feeder loop is going to be handling and how we're going to size those things. So hopefully we can put a couple little thoughts in your mind about how to do that. So I've added a cap for future use so that we can place those around the drawing. I've got my controller, and then adding pipe restraints. So we have those restraint fittings, and you can see that we've got right here joint restraint fittings, and if we click new, you'll be able to choose from these three different options. So fitting to pipes, and then valve to pipes. So depending on, I might suggest adding each one of those to your project, because you're going to run into different scenarios throughout the system that you're going to want to do. I've just added the fitting to pipe and pipe to pipe just to show those off a little bit, but obviously showing components just right off the bat, you can see what kind of options we have as we are connecting to fittings. So we have the ability to hook them to T's, to 90s, to 45s, and then a couple smaller angles based on Harco's availability. So there's those guys, and then obviously pipe to pipe type of fittings connections there. So Jared's done a really cool thing where they actually get integrated into the main line, and they recognize, so you can pipe to them and fit them within, so they're recognized. So we'll go over those a little bit more in a little bit. So from here, let's just go over what I've got thus far in the project so you can sort of get a sense of what's going on. We've got our point of connection up here. We're just pulling off of a well, and I've got an entire looped main with a couple cross connections here. So at each of these points, I have placed my gate valves so that I can turn off any one of those at any time. I haven't placed them here just so we can place them. So just right off the bat, I am going to place some of these so that we can see. We can place them either open or closed. And you'll notice that once I click it onto the main line and set it on there, it recognizes it and it actually hooks it into the system. So it does weld itself in right off the bat, which is actually pretty slick. You don't need to place them first. You can actually place them afterwards, and they will hook themselves together. So that does make it really, really nice. We can place a couple up here and just get them back into that system. So making sure that we have all of our connections there. You'll notice that I have placed these gate valves on mainline only, like our actual main feeder line. But you'll also notice that I've got gate valves going to each one of these fairways. And the really, really cool thing about this, and Jerry, you can explain it a little bit more. I'm gonna do my best shot at explaining how you explained it before, but the system does not, or the computer doesn't know exactly what you're intending to do. It does not have eyes, and it does not see that visual representation that this is a sub loop and you're trying to size this a little bit differently. It only knows the difference between mainline pipe and lateral pipe. And the way that Jeremiah was able to sort of figure this out, or let the system figure out, is pretend like the system was blind and using Braille. So it's feeling along these main lines, and it will sort of feel these different gate valves, and it'll feel just past them and see that it's actually different material, so it'll actually stop. Because what it doesn't want to do is it doesn't want to take out all instances as it's sizing these lines and continue to go through these unnecessary paths. So it's actually taking and it's stopping at these certain points and then doing different calculations within the system and placing them at a point where it can grab that information and send it back appropriately. So it's actually really, really cool, how it's actually processing through that. So making this sort of irrigation design as we would normally see it, where we've got two main feeds into this subloop here. We've placed all of our heads and we've connected them to lateral lines. We want to make sure that we actually put gate valves or shutoff valves in our two locations so that we can then start to split the flow accordingly. So I am going to leave that at that. Jared, do we have any questions up until now?
So far.
All right, cool. So we're going to drop in a flow zone here. I've already put one in, but I'm gonna show the power of these things just right here real quick. So to get to our flow zones, we're going to do that in our sizing mainline tool. So when we go to our size mainline, we're going to have the option to select a new flow zone. So what this flow zone is going to do is you're going to put the max flow that you want to limit this area to. Flow zones do not create flow. They only limit flow. And a step above that is they actually only limit flow if the flow in a given area exceeds that of which your flow zone is. So if you have an area, for example, this right here, that has, let's say, 30 GPM total in it, and you put a 45 GPM flow zone around it, it will not touch that. It'll size accordingly to what your flow is through those pieces of pipe. So we only are caring about what the maximum flow is for a given area is that you want. So we will do, I'm just going to copy the same thing. I'm going to say it's a 90 GPM flow zone. And you need to make sure that you encompass everything that you want included in this. What the flow zone is going to look for is both the end points of a pipe and the midpoint of the pipe. So as we come down into this area where we want to include, from the gate valve up through, but not necessarily our main feeder line, we can simply come around it just like this and include the entire length of our downstream of the gate valve and make sure that's all included, but just simply go up through and not include the rest of that that main feeder line, and you are good to go. So if I come across it this way, you're going to see that I can close it off, cancel so we don't size the line, but you're going to see that I got now a 90 GPM for this area. I'm going to do one more flow zone. We're going to give it 45. And for this one, I'm actually going to do the opposite. You really don't want to overlap flow zones other than, including some of the similar areas, but you can, cross through enough to where it's actually recognizing, the pipes that you didn't hit with the last flow zone. So you'll notice that my 45 GPM flow zone will include this connection lateral or this connection main here, but not include the pipes that are within the other flow zone. So doesn't matter that it's crossing through heads, but you can actually see if I select this, I've encompassed the entire 3 points of that line, which means it's going to be included. So you do have to be a little bit cautious and meticulous about how and where you're placing those flow zones, but it does make it really nice that it does pick up only what's within that entire area. So you are free to move these around however you see fit after the fact. Another really cool feature is the fact that you can just double click into that text and change this to whatever you want it to be, and that's its new flow zone. So you don't have to worry about starting a new one or deleting this one to change it. All you do is come in here and change that number to whatever you want it to be, and you're good to go. So now that we have our flow zones on here, the system's going to recognize that regardless of how many heads we have in this area or the total flow, we are going to limit it to no more than 90 GPM at a time. So I can actually use my View Data button. I can click on one of these heads, and this is something again that is probably already known coming into it. What type of head you're using, how much flow is going through a typical head, how many I can usually run at a time. But now I can see that these are going at 23 GPM. So now you can start to think about, all right, so how many can I actually run up until 90? So I'm breaching the 4 or 5 mark here. So we know that at any given time we'll be able to run up through that many. So a 45 flow zone, I got 31 per head. So as the system looks at this and it adds this next one up, that's already breached the 45 flow. It's sizing it to only run one at a time here. So you can really limit and force the pipe to be sized accordingly, and then we can worry about how those are going to run later down in our schedules. So I've got my flow zones put across the heads that I've placed already, and the other feature of that flow zone, then using the highlight station tool, you can click on a flow zone and it'll show you what's included. So if you're ever worried about what's actually included in instances like this, simply click on that flow zone and it will highlight everything that it is included. So it does make it really nice, quick check to see what you got going on in there. So from here, we're going to talk a little bit about our I'm going to place a couple heads here so we can go over our difference in mainline and lateral line here. So I'm actually going to place it from my rotors. And you can see that I got all my different nozzle choices. This specific one, these are all fulls here, so I'm just going to open up this guy by double clicking, and you'll see that I'm given that nozzle choice. Using my Q and E buttons, I can increase or decrease that nozzle size, and A and D to decrease or increase the radius, which is some of my favorite buttons. So we're just going to choose, and again, forgive my my awesome design skills here, but we're just going to really quickly do a one row design across here just by quickly placing them here. The other thing to think about, obviously, as we're going, just general rules of thumb, is think of this design stuff obviously just like you would any other type of irrigation system, and zoning is definitely crucial. So being able to water the greens different than the fairways is something that should be thought about. Head placement is definitely different when it comes to that. So I'll grab a different type of head that I can actually do some varying arcs on, and simply just place them in here and place them around the greens so that we have somewhat of a a better representation of how that would go here. So we'll just place a couple more. So here, so now essentially when we've done this, we do have to then, consider our flow zones for these different areas. We want these potentially running at different amounts. So we could place our flow zones as such. We're going to just pipe really quick. So one of the cool features as you place that valve and head rotor is you can actually use lateral pipe to hook these heads together, and it will be considered mainline. So we'll just use our lateral pipe function. I'm going to go from here. I'm going to use the just cheat a little bit and use the H command to have head snap on. I'm just going to drag across all these real quick. So when it comes to an area like this, obviously we can figure out what we want to do. I'm going to just pipe around to it a little bit like this. We'll pipe back onto it. Now we're going to have to put in our gate valves here, so I'm going to plop on some gate valves really quick, and I'll place one right here, and I'm going to place one right here. So when we pipe this stuff, we want to bring our main line into the gate valve, and that's going to be able to then assign that gate valve sort of that threshold or that gate into our lateral connection here. So the system's going to see that as different once we actually connect that. And I actually missed the mark there. And connect it in. So from that point on, the system's going to know now to treat this a little bit differently and sort of overlook it for the main feeder line. So we're going to connect that last one in here, and we'll bring him in. So now when we highlight this station, you're going to see that it only highlights up until those gate valves, which is pretty slick. It'll show the main connections in blue, in cyan, and then if you highlight the rest of the line, it's going to sort of bypass those sublines and treat those a little bit separately. So it's just an awesome cross-check there. So from this point, we can drop in our flow zones if we would like, size our main line, choose flow zone, and we can give it, based on what parameters that you've given it, we can assign 1 to 50, and we can include this entire thing, and I'll give that one 45, and we'll just drop one here. And again, keeping in lieu of this, we'll just go around that guy. So now I have my 2 additional flow zones. So we could stop here, but for time's sake, I'm just going to keep going unless, Jared, there's questions.
Go.
All right, cool. So what I've done for schematic, so this is, we just showed sort of placing those heads, how to use the lateral pipe command and stuff like that. But what if you didn't want to place all the heads yet? We sort of come up with a kind of a slick little way to at least account for some stuff. I obviously ran a valve schedule to see what my precip rate was for these given areas, so that I had a relative precip rate that I can use for this. But our schematic areas allows you to add different irrigation zones. So what I did is I added a couple different scenarios. So depending on how I wanted to water the greens versus the fairways, and if I wanted them with a couple rows of sprinklers versus just one row, I got a couple different ones here. So I've got him with his specific precip and a set pressure, and I've done that for just a 2-row as well. So I can now go ahead and place this stuff in these given areas, and it should respect that and drop in a flow. So now if I come into these bigger areas, I can go ahead and grab my other guy and go ahead and place him. And without clicking any more than those 3 times, I can start to get a sense of how much flow is going to be required for these areas. So that alone is pretty cool. But now how do I turn that into the ability to size my main lines accordingly? Since schematic is not recognized without valves, we can't just hook this to the main line. However, we've talked, and it would be kind of a cool feature. So I'm going to let that up to Jer's brain. But what we're going to do is we're actually going to place a cap. So we're going to come up to our equipment, and we're going to place one of these caps. So this cap, and caps also won't be in the valve schedule or the runtime schedule, but what it's going to do for us is it's going to be pretty much like a flow zone. So the cap isn't going to reflect the entire flow of that area. The cap's going to reflect what the flow zone for that area would be. So for example, I'm actually not going to place it yet. Let me show you this little nifty trick. With highlight station, if you highlight this sub main right here, and it's going to show us what's all connected, you'll see down here in the command line the total GPM for that area. So we can start to get a sense about what it is going on through that area. I got 910 GPM going through there. So as we look at these different areas, we can start to sort of get a sense of if we're close to the same, what my flow zones were for that area. So I'll stick with the same or similar flow zone amount. And if I just simply place them in here, since it's not going to matter, we're not doing a looped here, we're just connecting from our main to this cap, I can actually place them just outside. That should be okay. But we'll go 85 for our flow zone here. And the pressure we'll do set at whatever the design pressure is for that type of head, and we'll place them in. From here I can place my valve for my isolation valve, and now I can pipe to him. So essentially it's a lot simpler of a just pipe to one thing, pipe my valve to my main line, and now essentially I have set up for this entire area what this will be representing right here. So we at least get our demands that will feed the main line, so the main line should size just fine like that. So having those in there, we can go ahead and place other caps in. Obviously placing the caps, I think the easiest way to do that would be to simply place the cap, put in your flow, your pressure, and then copy before you pipe. Copy that guy around to any of these specific areas that you've got going on here, and then change that flow just by double clicking on it and changing it to a more appropriate amount for whatever that given flow zone is that you want. So we'll go just like that, and now we can pipe to these different areas and hook those all in, and it should be a pretty accurate representation. So let me quickly do that. So while we're on the topic of placing valves and stuff like that, the quick coupler valve again is kind of a neat little feature. The quick coupler valve, if you place it on the main line, and I'm talking about the actual main feeder line, what it's going to do, since it doesn't have a flow or anything assigned to it, it's going to actually assign the minimum size pipe as it sizes the pipe to it. But you can also connect it within one of these flow zones to a lateral pipe. So the lateral pipe typically wouldn't be able to handle a quick coupler because they're a valve and they go onto the main line. But since we have the ability to treat this lateral line as main line, it will allow it to be placed so that we can actually put those quick coupler valves, in the system right where they're supposed to go, and they will give the minimum lateral pipe size to those if we pipe to them. So pipe those guys real quick. Pipe that guy real quick. So this is going to sort of complete us. I didn't add a valve there. Let me hurry and put him in. Now, I'm sure everybody's used the quick coupler, or not the quick coupler, sorry, the isolation valves, and knows that you can use our view data button to be able to turn this on and off, or open and closed. Now, going through an entire site, an 18-hole course, or even just a 9-hole, but more valves in general, it's going to be a little time consuming to go through and click on each one of those and close them all and then open them up as you need them. I think I even showed Jared this. He didn't even recognize this, so I'm gonna take credit for it. But being able to use your match properties for this is a great time saver. So what I'm going to do, just for the sake of this example, is I'm going to show this guy closed. And I want to close everything up except for one specific loop. So as soon as I say close to that, he actually turns a different color. That's super handy to have a visual representation, but I don't want to have to go through here and choose each one of those to close them, because I got, I don't know, a good 20 or 40 of those things in the project. So what I can actually do is use my match properties button, select that source object, so I want it to be closed, and I want a destination object. And I just click on one of them. You're going to see that he turned pink, but I could go through and I could keep clicking on them. Since I clicked on one destination object, I can actually window across this entire plan, and it's going to only recognize that isolation valve. So I just did all of them, and you're going to see every one of those is now off. So in a matter of 3 clicks, I was able to do all 30 or whatever I have in there at the same time. So now it's a lot easier to just go in to the specific zone that you want to have open for this running of the valve or running of the main line, and open up those 2 valves. You can also do the match properties again and highlight the ones that you want open. So it goes both ways. I am, however, going to leave everything open so that we can take a look at how this actually runs. So let me just hurry and turn those back. All right. So the next little tool, we got our spot elevations in here. Something key to know is that if you have one spot elevation in here, and we got to use land effects as spot elevations, we can't use any just typical dumb elevation. It's got to have that data tied to it so it knows what to look for. But if you have just one elevation in there per hole or per fairway there, the system's going to start looking. Any equipment that registers that kind of stuff, so isolation valves, the heads, the point of connection, it's going to draw a circle around that thing, and it's going to find the closest elevation and apply that to it. So for example, this guy right here, if I drew a circle, he's going to grow out, and looks like his spot elevation would be right here at the 49 feet. And so it is suggested that you are very liberal with your spot elevation placing at those key spots. So simply placing a spot elevation closer to and having that be at 45 instead will definitely help with the accuracy of the plan. So really hitting those in all of the plan is definitely going to be a must. So once I've got everything sort of elevated or spot elevated there, I can then use my verify. Now I do want to use that verify mainline so that I can actually see what it is that's going on, not only because it's the first level of that error checking, but if you just proceed without it, you're going to get results and you're going to start questioning them. So starting from this verify stage is definitely a time saver. So it does look like I've got some missing callouts, but everything's connected to a water source. So let's just take a look and see. Oh, I didn't call out those guys. Oh, and I didn't call out these guys. So since these are valve and head, I mean, by definition, it is one head and it has a valve in it. So how do we label these things? It's pretty cool. This was my first time labeling them and realized that it is not like a normal valve callout, but you are using the valve callout button. So using the valve callout button, it's going to work just the same. You're going to be clicking on the actual head, since it's a valve and head, and it's going to recognize, what it is that that we need to call it. Now, I did do this on purpose so that we can show this feature off. Just like our regular valve callouts, I've gone sequentially through here. The next one should be A9, or A10 here. So I got 9, and I should pick up with 10 here, but I actually skipped over them and put them started here. So it does have that same great feature that I can simply click on it and say A10, and it gives me this message that that's in use. And if I want to duplicate it or increment, I'm going to hit increment, and you're going to see once I place this guy right next to it, it's not going to give me the arrow style. The plans here will just get super messy, but lets me drop it right there. But you can see that everything else switched from there. So I can continue to go through and say A11, hit increment, and place it. So it does make it super nice when you do make those little mistakes to be able to have that option there to go. So once I get this here, increment. All right, so it looks like we're good there. And I ended at A47. Now I am jumping across here, and you're going to see that I did initially end with the next number, but I am switching controllers here because golf courses have scattered controllers across the site and large runs. So I did want all of these valves on a different controller. However, I did leave off now here at 47, so I do want this to be 48. So all I need to do is call this one B48 and increment, and that should have gone. Let's try this one. Increment. Interesting. We'll have to take a look at that. I was hoping it was going to increment my stuff. So we'll move on from that. We're going to just leave these guys called out for now. But you're going to see I'm going to click on my size pipe. Now here's the next thing. We never actually went over this, so I guess now is the best time than ever. Go to our source data. in our irrigation manager, under source data, I have set up a pump station and well where I know my max available is 1,000 GPM, and my pressure is at 160. So I know I got a lot of flow, and I got quite a bit of pressure here, but also it's a big site. So just knowing that overall flow that you have available, we are assuming that we're running multiple valves at the same time. Since they are just single heads, you know that you can run a couple heads at a time. We do want to say we are going to max out at whatever our available flow is. We want to just try to get as much out there as possible by putting that there. However, we are using flow zones, so it is limiting the flow to those specific areas. So it's not going to just size everything at the 1,000 gallons a minute. It's going to size it based on what we've restricted it as. So this is going to be that powerful feature of that main feeder loop versus our sub main laterals. So the option to use spot elevations, obviously we want that, and we're going to hit OK. So this is going to think through. It's going to recurse. What I should have done is zoom out, and that'll be a lesson to me. It's easier, I think, for the system, Jared, correct me if I'm wrong, if it is zoomed out to its extent so that it doesn't have to do what it's going to do next. Is that correct?
Yeah, that's right, because it'll be doing zooming. Yeah, it'll be doing some zooming to calc the precip rates for
right.
each head. And so, as you can see there, you see how it zoomed to see that one rotor. So.
Yeah, that was actually in my notes to say make sure you zoom extent. So this is showing you what it does if you don't. If you simply zoom out so it sees everything, you'll just see what pass it's on and what instance of that, those different routes that it's taking. So it is going to take just a second. This is a good time for a joke, I'm sure.
Oh, you mean like when the guy returned from his golfing game, and his wife said, "What the heck happened? You look horrible." And he's like, "Well, Harry had a heart attack and died on the third hole." And she goes, "Oh my God, what'd you do?" And he's like, "It was horrible. You know, it was hit the ball, drag Harry for a little bit, hit the ball, drag Harry for a little bit."
Yeah, I think we can go for one more.
I don't know.
All right. Well then, do we have any questions?
All the other ones tend to be naughty, you know. But no, actually, Stefan has a great question. So he was wondering if the spot elevations can be in an XREF, and that's a great idea. I just never thought of that before, because we can certainly access the plants that are in an XREF. There's no reason we couldn't support having spot elevations in an XREF. And so I think that's definitely something we could add. We just want to get some sort of toggle, because a lot of things need the spot elevations. We certainly don't want to slow down all of that by having them have to scan every XREF looking for spot elevations, which could take a very long time. So we would just need to ponder a somewhat intelligent way to do that. But I can certainly see how handy that'd be to be able to have your spot elevations XREF'd into your various plans.
Cool. All right, so here's what I was talking about, Jer. The system, and this I think is just going to be finessed in the code. The system's saying that you need to size lateral lines. There's actually no lateral lines that exist, because if you do try to size lateral pipes, it just doesn't do anything. But if we were to size the main line one more time, it actually will work. So I think it's just a firing it twice deal. Something
Clearly,
like that,
you must
maybe.
have broken something.
I clearly did. It is all my fault. So, let's see here. While we wait for this, no more questions, huh? I'm doing such a stellar job.
You're doing a great job. Um, and um,
Well, I got a little something to say.
I'm better when I mute myself because I don't mumble, huh?
That's okay. Yeah, you can mute yourself. I'll talk for a second. So, a really cool little command, and this has nothing to do with the golf course irrigation stuff, but um, as we're dealing with plans, obviously XREFs are a big factor in keeping things clean and how we recommend working with your base files and stuff like that. Um, I've come to love this little command, and if those of you who don't know it, it's ncopy, N as in Nancy, copy. And Amanda actually showed that in one of her webinars once, and I just simply loved it, because what it does is it actually goes into, or it recognizes polylines and closes polylines in XREFs or nested polylines. So you can actually be in this current drawing, and the way I was able to do those schematic areas was type ncopy and click on one of those polylines. I didn't have to open the XREF or anything, and it pulled, hitting enter 3 times, it pulled that stuff into the current drawing. So it's kind of a really neat, fun little way to recreate boundaries and areas that are within XREFs. So that's your tip for today for that. So let's see here. Even the second time I didn't zoom out. I don't learn a lesson, apparently.
All right, so this guy is struggling for this golf shot. He's in this big tournament, and the old timer groundskeeper is like, just shoot it right over that tree. You'll get there. So he's like, I'll try it, you know? And the old timer's like, yeah, I used to do that all the time. That's how I won the championship. Anyway, it hits the tree and goes in the water, and the old timer goes, oh, but that tree was about 3 feet tall back then. Huh? Huh?
That's a good one. That's a good one. I hear everybody laughing.
You're like, please finish sizing.
Make that faster. All right, so check it out. We got obviously have a decent result here. Decent in that we have way too much pressure available for my little measly system. But you're going to see that its design analysis here is using that maximum flow of 1,000. Which means it's going to use it all, but it's obviously not using it all. So pressure required at the critical station, we've got 68 psi going through the main line, and now it's even recognized that we're gaining 6.5 pounds from that POC down to the valves or those heads. I don't have a backflow, so I'm not losing anything there. So I've got a very big pressure available, which means one thing: I either get rid of some of that pressure, or I better make sure I have joint restraint fittings on everything, because that's a lot of pressure to have left over. And pressure reducing valves, you name it. So you'll notice that we now have a sized main loop, and it seems pretty consistent across the board that it's sized at a 6-inch. And you can see, if we were to use our view data button now, clicking on any of these T's coming off into this area, a GPM of 45, and this one should match a 45. And that's because it knows that this is a 90 GPM flow zone here, and I've got two sort of a loop system into it, so it's splitting the flow real nice and even, and it's given me that constant, that consistent flow across the entire loop, which is pretty nice and slick. So when you come into these areas, the reason that this flow zone is pretty important, why you wouldn't put it in with the same, is because this isn't a loop, and so it's actually treating 45 coming this way and 45 coming this way. So essentially, if I didn't have this 45 GPM flow zone here, it would be sizing this guy back up to 90 GPM. So we're definitely going to want to keep this guy consistent with the rest of the system, and that's why we've sort of forced it back down to use that right there. So pretty nice. As we're coming along here, I got 60 GPM, so it's gonna again split the flow 30-30 and really only give me, I think this is a great example here too. I had 45 coming into these areas, but you'll see here I only have 23 GPM because that's all that's needed to feed this head. So it's sizing it based on its needs, not just on everything else. So you will notice, however, that it only gave me labels on my main line. It could get wildly confusing and sort of error prone potentially if it started just throwing sizes on everything else. So we do leave that one up to the designer to choose where they want. It does already have a size associated to it, but you'll be able to just drop in that label wherever you see fit for that design. So doesn't make it that much more difficult to do, but it is that way on purpose. So for that, we're going to move into summary, the run times and stuff like that. Do you have any other things you want to add to that, Jer?
Time would be fantastic.
All right, cool. So just like everything else, we have all of our different schedules. Being able to run our regular irrigation schedule is going to list out. We even have our schematic irrigation so we can see how much that's putting out. But listing out all my different valve and head rotors that I've got in the system, along with a broken down version of those pipe restraints that I've actually placed on my lines. So that's pretty nice. Again, our POC, and then our pipe breakdown for sizes. So there's that guy. Our valve schedule, super helpful in just troubleshooting stuff, let alone obviously just great information. But you're going to see, you're going to be able to pinpoint, I guess, rather, a lot of maybe issues that you have here where it says these are unknown valves. Those are the ones that I haven't labeled yet. So being able to just pinpoint right where there's some issues with stuff, if you don't see a precip rate for some reason, or if you don't see a wire length for some reason, there's definite troubleshooting ability right within this thing here. So again, we've made this really nice to where it does recognize the closest controller. So if I have, you know, a set of everything that I want on my A controller, it is giving me that wire length from that head, shortest route over to that controller. And then my B is right here. So you can see that these lengths are a lot shorter than the rest of the A controller. And that's because my B controller is chilling over here pretty close to all of their heads, versus the A controller where I got heads clear over here and my controller is right down in between them all. So there's definite improvement that we're focusing on, and how it knows what controller to hook it to. But for now, you know, being able to have that ability to get that quick snapshot is definitely something to not really shake a stick at. So the last one that we want to really focus on is this runtime schedule. Given different programs, the descriptions, how many stations that you're going to want at a time. Again, the system's going to be really acting as if it was a smart controller in this realm, and it's going to allow you to set whatever the parameters are for that. So I've already determined, you know, that I have the ability to, or I want to be able to put down 0.28 inches a day. So roughly 2 inches a week. And I want that to be sort of the determining factor here. And I'm going to simply, I'm going to say 10 stations at a time, but it's going to really go through and it's going to look for different combinations for that. So I'm going to hit summary here. I'm going to place him in the drawing. And you can see this isn't the best. I'm still, all I know is, not all I know, but the main focus that you're trying to get here is a perfect square, a perfect rectangle of a shape. Especially when you're dealing with pumps and stuff like that, you really don't want this fluctuation and this dragging out of over this amount of time or on and off type of a thing for that pump, just wear and tear on it. So the more consistent that you can have things running all consistently, and then finishing out is obviously ideal. But you can control that with the types of heads, the mainline size, the different combinations of valves of that nature. So, Jerry, unless you want to give the description you did to me earlier today, this is sort of our runtime schedule that lets us know how long it's going to actually take to water.
Yeah, and you can definitely, I mean, like just if this was your finished product, for instance, you would probably then immediately want to, because obviously something's going on at the end. So you would want to do the run times and see what the heck is happening at the end there, because that's just trailing on too long. And what you could do is go to the end and see which valve numbers are those that are taking so long at the end. And what it basically is of course just a matter of how they're piped. So now you can see, okay, so it takes a long time for it to cycle through all of those heads. And that's just, either you're going to need to accept that long of a watering window, or maybe you want to try, if that is too long of a watering window, then, you're going to need to maybe consider upsizing the pipe. Because, that's going out however many hours, and but as a analysis of that kind of a runtime curve, that's what you're supposed to be able to notice, is that it starts out pretty good and there's a lot, you're really maximizing your flow, but then those ones in that fairway are just effectively taking too long. That's not optimized. Maybe another entry point or something like that.
Right. So yeah, the final one, like Joe was saying, the runtime schedule. It's definitely going to go through and sort of do a breakdown of what controller will be running, and at what point things start switching and turning on and off as you go down, so you can start to get a sense of how it's really coupling these things together. This was always the most confusing part to try to put together, which is awesome. The complexity and the thought that went behind, as Jared was explaining to me, the way it looks for things and starts turning stuff on, and then just goes through all the different scenarios and what flow zone it's in, and how much flow is left over in that zone, and can it add another head onto that without breaching that flow zone, and where to look for it and stuff. So it does go through, and it does couple it and combine it with sort of like instances as it starts to go through. So it does a pretty stellar job. So with that, I think we're at our time, and all we had planned to show, unless there's any last questions.
So yeah, no, I was able to get the little questions answered there. Like you said, that feedback of getting spot elevations in an XREF, great idea. And the other one that came in was possibly putting the XY coordinates in the valve schedule. Might help for maintenance or geolocating. I thought that was a really good idea. That's too. Cool. Anyone else? Yeah. Anyone has any great ideas like that, feel free to let us know. I don't see any questions coming in, so of course, if you think of something over the weekend, try to write it down and send us an email on Monday. And otherwise, I guess, have a great weekend.
Thank you, guys.